All right, here is the part 2 video of the lesson 812. Sorry, things started to get a little rushy there at the end of the first one. I just wanted to fit it all in without getting cut off. But we're going to pick up here at 8-17. I'm going to work a little bit slower. The goal is to get through 8-19. Maybe I only get through one, maybe two problems in this video, but I want to slow down, make sure it makes sense, and just give you that opportunity to try to complete some of the other ones through the rest of the lesson, whether it's 8-18 and 8-19 or whatever I leave you with, okay? We're still talking about these sinusoidal functions, sine and cosine, modeling these real-world situations. And again, we're going to take the high points and the low points to really talk about the amplitude, the period, the vertical shift, and the horizontal shift to create a function. Once the function is created, we'll put it in Desmos and then answer the questions B and C. Here on this one, and again, because I'm going to stay consistent to what I did last video, I'm going to do another cosine problem. And remember, if we're going to do cosine, we want to start with the high point into the low point, okay? What this says, and again, you can read the problem. This one's a little bit shorter, but it says that we are continuously riding this bike at a constant rate, and at the time, 1.25 seconds, the gum is at its maximum height. 1 second later, the gum is on the ground. It says if the diameter of the wheel is 68 centimeters, then we're going to write the equation to model the height of the gum above the ground. And this, again, is going to be represented by this sinusoidal function, specifically cosine. So let's start with the first point, which is going to be at, let's make sure my pen is on, at 1.25, we are at the maximum height. And the maximum height is going to be 68 centimeters because that's the diameter of the wheel. So if the whole wheel, this is a terrible drawing, but that's the wheel, that's the height of the wheel or the diameter of the wheel, at its highest point right there, it would be at 68 centimeters. And that would be at 1.25 seconds. So at 1.25 seconds, we're at 68. A second later, we're back at the ground. And so a second later, that's 2.25 seconds. We're on the ground, which is a height of 0. And we can again use those 2 points to talk about the period, the amplitude, vertical shift, and horizontal shift. Let's start with the period, okay? Similar to what you saw in the last video, it takes me 1 second to get halfway through. In another second, I would be back up, because we're working at a constant rate, so 3.25 seconds, we'd be back up at 68 centimeters. And I'm going to run out of, that didn't work, but that would be 68 there. Sorry, ran out of room. So that what that means is in the full 2 seconds from 125 to 325, we've completed one full cycle, and so that means my period is 2 full seconds. Okay? The amplitude of the function, and this one has been a little awkward to talk about, but the amplitude of this function is, again, the height from that midline. The midline of this function, you could, again, to figure that out, you can always take your values, 68 and 0, add them together, divide by 2, and that will find the midline. In this case, the midline is at 34. And then the amplitude is the height from that midline to the highest point or to the lowest point. In this case, if my midline was 34, it takes 34 more to get to 68, or it takes 34 less to get to 0, which tells me the amplitude is 34. Okay? Now, the horizontal shift of this function, so that is how much did I shift over to get my highest point, because this is a cosine function, and the horizontal shift was, it was shifted over 1.25 units. The vertical shift is where the midline is at, and the midline is actually in this problem the same as the amplitude at 34. Remember, because that midline is really your vertical shift, 34, your amplitude, so your amplitude more than your vertical shift brings you to your highest point. Your amplitude less than your vertical shift or your midline is your lowest point, which is 0. So 34 plus 34, that's 68. 34 minus 34, that's 0. So that means that midline or that vertical shift is 34, and I can write the equation from here. This is again a cosine function, and that cosine function is going to be represented by h of t. The amplitude is where we start, and this has an amplitude of 34 times the cosine of your period. So remember, it's 2 pi divided by your period, so that's 2 pi divided by 2. 2 pi divided by 2, which the 2's would cancel and really just be pi. I'm going to leave it like that for now, though. 2 pi divided by 2, t minus your horizontal shift of 1.25 plus your vertical shift of 34. That's your equation that would represent this situation. And again, the 2's would cancel, so that's really just like pi times that whole thing there. Okay. Now, again, I have that graphed in Desmos. What it says here is it would say, what is the height of the gum when Lamaze gets to the end of the block at 15.6 seconds? That's just like plugging 15 into your t function, and let's do that on Desmos. So the function, you can see it's right here in my number 2 line, 34 cosine of pi, t minus the 1.25 plus 34. If we plug in our value of t, which was 15.6 seconds, that gives me my answer of 49.43 for the height. So at 15.6 seconds, the gum is at a height of 14.435. Now let's go back to the curve itself to answer the next question. Now that's pretty messy looking right now, but we can zoom in and try to make this a little bit better. There we go, not as bad. And what the next question is asking us, I want to make sure I'm on the right one, here it is when are the first and second times that the gum reaches a height of 12 centimeters? Now to answer that using Desmos, I'm going to do a y equals to 12, which would represent a height of 12, and the first and second time that that happens. The first time, that's negative time, so we're not going to count that. The first time is at 0.56 seconds, we hit a height of 12. The second time is at a 1.974, we hit a height of 12. So it would be those two times, t equals 0.526 and t equals 1.974 to figure out that problem there. All right, we're going to get rid of this, and then we're going to move on to the next one, and then that's probably going to be it for my time. Hopefully at this point we're doing okay with it. If we're struggling, again, I know it's not ideal with me being virtual and making videos, but you can always ask me questions, and I can make further video guides, and I'll try to clean everything up when I get back on Monday. So in 8-18 it says, Amanda is watching her little brother Mike play on a swing set. I don't really need to read it. You can pause it and read it yourself. The big part of it is that she finds out that at t equals 2 seconds, that Mike is at the highest point, and he reaches his low point at 1.5 seconds later. The greatest height is at 9 feet. The lowest height is at 1 foot. And so again, we're going to take 2 points and use those 2 points to model this situation. And just to stay consistent, we're going to use cosine again. I will talk more about sine in maybe tomorrow if I do a day 2, or talk more about sine when I get back. But let's think about the first point. So the first point is at 2 seconds, and at 2 seconds we're at the highest point, which is 9 feet. The next is 1.5 seconds later, so that's 3.5, and we're at our lowest point, which is 1 foot. 1.5 seconds after that, which would be at 5, we'd be back at the high point of 9. And that just helps me see that the period here is 3 seconds. Because to go from the high point back to the low point back to the high point took a total of 3 seconds. Okay. The amplitude of this function is, well, we can figure out that midline by taking 1 plus 9, that's 10. 10 divided by 2 is 5. Okay. So from 5 would be our midline. Well, to get up to 9, which our highest point would be 9, that's a difference of 4, okay? To go from 5 to our lowest point, that's also 4, so my amplitude is 4. My horizontal shift over, let's see, can I fit a, no, I want to start at the first high point because it's a cosine function. So my first high point is at 2. If I went back 1.5 seconds, I'd be at a low point. I don't want to start at a low point. It messes everything up. And so I got to start with that first high point at 2 seconds. So I'm shifting horizontally 2. And vertically, I would start at my midpoint, which is 9 plus 1 divided by 2. That's 10 divided by 2, which is 5. And I have that vertical shift of 5. Again, the amplitude and the vertical shift go hand in hand. 4 more than 5, that's the 9. 4 less than the 5, that's the 1. Now I have all the pieces to set this up to write the equation. The equation being h of t, and it's a cosine equation. And I have the amplitude being 4, so 4 times the cosine of my period change, which is 2 pi divided by what I call that p-value, the period, so that's 2 pi divided by what we have as 3. It's 2 pi over 3, t minus the horizontal shift of 2, all closed off, plus the vertical shift of 5. And that's my equation now representing this situation. Let's go to Desmos and try to answer some of these questions. The first question is pretty similar. What's the height at 5.4 seconds? Well, that means I can take my equation, which is represented right here, 4 cosine of 2 pi over 3, t minus 2 plus 5. I need to figure out at 5.4 seconds, so I'm going to put 5.4 into here. And it gives me a height of 7.677 if I rounded it up to right here. That is the height at my time. That answers that question for us nice and easy. We go back to t and we actually graph it. We get this equation here. And it's going to ask us, when are the first and second times that Mike reaches a height of 7.2 feet? Similar to what I did last time, I'm going to set a y equal to 7.2. The first time it happens is negative. I don't want to take that one. I want only positive. So the first one's actually here. We get to a 7.2 height at 1.528. And we get the second time at 2.472. I'm going to leave you here for 8-19. You can try to do this one with cosine. Try to do it with sine if you're feeling really dangerous. I may pick up with this one tomorrow. We have a couple more. I think I'm going to stick with this lesson and just keep doing video guides to help us along. I like this lesson. I like this idea. I would like us to get it. And I think taking a little extra time while I'm virtual here isn't a bad thing. I appreciate if you've watched the entirety of these videos. If you have any questions, please reach out through email. Again, I know it's not ideal, but do the best you can to learn while I'm away, and I'll keep making videos through the rest of this week and try to hopefully be in a decent spot when I get back next Monday. All right? Have a good day, and I'll see you again soon.